Hey everyone, so today I'm going to be telling you about stopping distances. And first of all, let me just give you kind of a common misconception, which is people believing that stopping distances are to do with the time that it takes for a car to stop. Because the key word is stopping distance, is not the time, is the distance that a car travels while you figure out that you have an obstacle in front of you and the car finally stops, okay? So the stopping distance comes to do with road safety, and it has to do with your thinking and braking distance. So it depends on both. It's the adding of your thinking and braking distance. Your thinking distance has to do with your reaction time. So when you are on the road, it takes you a while from the moment you see an obstacle until you press the brake pedal. The distance that a car travels during this time between you seeing the object and finally hitting the brake pedal is known as the thinking distance. The thinking distance can depend on several factors. So there are some factors that are going to increase the thinking distance, not just how fast you react to things, but there are some factors that increase it, such as, for example, being under the influence of alcohol or drugs, or both. Or being sleepy or tired or being on a phone and having therefore distraction. Any of these things will increase your thinking distance. Your braking distance, however, depends on the car and also the speed of the car. So once you press the pedal, the car starts to slow down, to decelerate, but it takes a while until the car comes from the initial speed until it finally stops. So the distance that a car travels since the pedal was pressed, or from the moment the pedal was pressed until it stops, is known as the braking distance. Now, there are some factors that also increase braking distance. The speed of the car increases the braking distance. The faster you are going, the faster or the stronger the force that you need to decelerate the car by the same rate. By the way, speed also increases thinking distance, okay? The road conditions, if it's wet or icy, then it takes you longer to brake. Also, if your pedals or your tires are worn away, this is also going to influence in a negative way the braking distance. Now, as I told you, the speed increases both thinking and braking distance because your car is still moving on the time that you are reacting to the object and braking the pedal, and then the car still needs to go from a certain speed to a zero when you're trying to brake. So this picture taken from AQA shows you how different the stopping distances are for different speeds. For 30 miles an hour, you have a total stopping distance of 23 meters, 9 meters for the thinking distance and 14 meters for the braking distance. This thinking distance is taking the average person. The average person, they say, react in about 1 second or half a second. If you want to look at your reaction time, go on this link where you have a game where you can check your reaction time with sight, sound, and both, okay? And then if you go at 70 miles per hour, your total stopping distance increases to 96 meters. So you have 21 meters of thinking distance and 75 meters of braking distance. And again, the total distance increases by quite a lot, okay? So let's do a couple of exercises, okay? So the first one, again, I took it from AQA, and I'm talking kind of generally how the braking force changes the braking distance, and therefore to do with the force changes depending on what you have. So the braking force needed to stop a car depends on the speed of the car when the brakes are first applied and on the mass of the car. We can see this using the equation resultant force equals mass times acceleration, in which the braking force is the resultant force. The greater the speed, the greater the deceleration needed to stop the car in a certain distance, so the braking force must be greater than at a low speed. The greater the mass of the car as well, the greater the braking force needed for a certain deceleration. So this is the theory. Now, how do you calculate? How do you get the numbers if you want to get the numbers for thinking and braking distance? Well, remember that speed equals distance over time. Therefore, distance is going to be the speed times time. The thinking distance will therefore be the speed of the car in the moment that you decide that you need to brake, times the reaction time, the time that it took you to see the obstacle and press the pedal, okay, the brake pedal. So that's the thinking distance. The braking distance is going to be the braking time, because again is speed times time, the time that it takes you to brake the car, but also multiplied by the average speed of the car during the braking, okay? Because you don't have just one speed, you are decelerating. So you have a range of speeds. So the braking distance will be the average speed of the car times the braking time. All right, let's just do 2 exercises to finalize this stuff. I have here 3 sentences. Decide if they are true or false. If they are false, correct them. A driver should leave a bigger distance to the car in front of him when the road conditions are dry. Although you should also always leave a good distance, a good gap, the road conditions dry or the wet road conditions are when you need to leave a larger distance in between the driver in front of you, okay? Because again, braking distance is increased because there is less friction on the road. The lower speed limit, 110, applies only when it's raining, and the higher speed limit, 130, applies when the conditions are dry. This is true. You can have different speed limits according to the road conditions and the weather conditions, because the road and the weather conditions will affect your braking distance. C. The picture shows different speed limits because the thinking distance changes with the weather conditions. Is false. The braking distance changes with weather conditions. The thinking distance does not depend on the weather conditions. I do understand some people say that sometimes when it's heavy rain and foggy, it takes you longer to understand that you have an obstacle, but the thinking distance starts from the moment you see the obstacle, so the weather conditions do not affect it, okay? Now, last exercise. Will the following increase, decrease, or stay the same? The thinking distance, or mobile phone, tiredness, and alcohol and drugs. So this makes that increases the thinking distance, okay? The speed of the car affects, is it thinking, braking, or both? Is going to be both distances. The faster you're going, the more the car travels as you think and as you brake. What will happen to the braking distance if the road gets wet? If the road gets wet, the braking distance will increase. Why will this happen? The reason why this happens is because if the road is wet, there is less friction on the road. Finally, how does the car's condition affect the stopping distance? Well, if the car is worn away or if the brakes are worn away, then the braking distance will increase and therefore the stopping distance will increase. So that is it for today. I hope it made sense. Up to my next video. Be happy and healthy. Bye!